Lesson 6.1, we're talking about populations and samples. So on page 312, example 1, 2,468 registered voters in Morgantown are voting whether to build a new stadium. Morgan and her friends really want the town to vote in favor of the new stadium. How can they determine how the voters will vote before the day of the vote? So what they do a lot of times to get an idea of this, how people are going to vote, is they do surveys. They randomly ask people, and that's going to be kind of what we're going to be talking about today. So one option they have would be to ask everybody. So asking everybody would be called asking the population. Population includes everyone. Okay, like we could say, you know, what the population of Indiana is, or the population of Evansville. Population includes everyone. So they could ask all 2,468 people. That would take a long time and be kind of difficult to do probably. So usually what's going to happen, rather than asking every single person, we'll just ask some people. So instead of doing the population, we might do a sample. So sample includes part of a group. We're just asking some of the people. So out of this group, we've got almost 2,500 people. They're saying maybe they'll ask 100 or 200 people. So that would be a nice sample there. If we only ask a couple people, you know, let's say we got over 2,000, almost 2,500 people, and we only ask like 5 people, that's probably not a real good sample, because we're not asking very many people. Okay, we want to make sure, obviously it's not convenient to ask every single person, to ask the whole population, but if we can ask at least some of them, a good number, you know, like here 100 to 200 people. 200, that's almost, you know, it's between 5 and 10% of the people, so that's probably not too bad of a sample there. So if you look at the try it, Miguel thinks the science teachers in his school give more homework than the math teachers. He is researching the number of hours middle school students in his school spend doing math and science homework each night. So the blank includes all of the students in Miguel's middle school. It would be?
The population.
Population, good. And a possible blank is some students from each of the grades in the middle school.
Sample.
Sample, good. Okay, so those are 2 words we'll be working with quite a bit in this lesson. So example 2 says describe a representative sample. So Morgan decides to survey a sample of the town's voting population. How can she know that the survey's results from the sample of voters represent the position of the entire town's population? So what she can do is do a random sample. So here's a couple more vocabulary words. Representative sample accurately reflects the characteristics of the entire population. So we're asking a good representative sample of people, then we're expecting that that's going to reflect how everybody in the whole population would think. A random sample, each member of the population has an equal chance of being included. So usually that's what we want to do. Make sure everybody's got a chance to be included anyway. And like the book says here, a random sample tends to be a representative sample. If we randomly ask people where everybody's got a chance to being asked, then that tends to be a good representation of the whole population. So if we look at the try it, produce managers deciding whether there is a customer demand for expanding the organic food section of her store. How could she obtain the information she needs? She could take a random sample of shoppers. Example 3, how can Morgan generate a random sample of the town's voting population? So to get a random sample, she could, first of all, needs to define what the population is. In this case, the population would be the registered voters in the town. And then she can choose the sample size. Here it says she's going to ask 100 people. Make or acquire a list of all members of the population. She could assign a number to each member and then generate a list of random numbers. They have stuff out there, I think, even where you can get it to just randomly generate numbers for you, randomly pick numbers between this number and this number. Okay, so that would be some steps she could do. If we look at the try it, Ravi is running against 2 other candidates for student council president. All of the 750 students in Ravi's school will vote for student council president. How can Ravi generate a representative sample that will help him determine whether he will win the election? Well, basically those steps that we just looked at right above there, if we just follow those steps, that would be a way that they could do this. Okay, figure out how many people we have, or what our population is. In this case, it would be the all the students in the school, and then he could decide how many people he's going to pick out, make a list, assign numbers, and then randomly select numbers. Example 4. Morgan and Maddie will each generate a random sample of the 138 students in 7th grade at their school. They each write the numbers from 1 to 138 on small pieces of paper, put them into their different hats. Then they draw 20 numbers randomly from their hats. What do you notice about the 2 random samples taken from the same population? And what does this tell you about the sampling technique? So a couple things the book's pointing out here is that there are 20 members in each sample. Each of them picked 20 people. The circled numbers are common to both samples. So in other words, both samples had a 38 and a 106. And the numbers are distributed differently in each sample. What do we mean by that? Well, if we look at Morgan's sample has 2 numbers that are less than 20. Okay, notice the bottom of our bar graph, that's telling, where our numbers are, and then how tall the bar is tells how many numbers are in that group. So less than 20 was 2 for Morgan. From 21 to 40 for Morgan, there were 3. 41 to 60, there were 4, and so on. What was the most common interval of numbers for Morgan? 81 to 100 is the most common, okay, because it's got the highest bar there. And then they did the same thing for Maddie. So Maddie's most common interval would be 21 to 40, okay? So you can see by the bars are not the same, so they have different distributions. And so it is pretty good randomness that we have. Out of 138 numbers, we picked 20, and only 2 numbers matched. So that's pretty good. That's telling us that we do have probably a good random sample here with how we did this. So the table at the right shows the random sample Jeremy generated from the same population as Morgan's and Maddie's samples. Compare Jeremy's sample to Morgan's and Maddie's. So I've brought this on the same screen here so we can see it a little bit easier. So some different observations we could make, just like the ones in the previous example. This one again has 20 members, so that would be one thing we could make note of. Okay, so we could say all of these have 20 members. The more samples we have, the less likely it is that we're going to have things being in common. In fact, if you look through these 3 things, there's not one number that happens in all 3 of these lists. Okay, we do have some common numbers again though between 2 of these. So we do have some numbers that are in common, not between all 3, but between 2 of the lists. 126 here shows up in Jeremy and Maddie's samples. Okay, so we could say 126 is in Jeremy's and Maddie's sample. And we could also say that 36 is in Jeremy's and Morgan's samples. So here we see 36. And again, there's not one number that's in common with all 3 groups. So look at the key concept, just kind of recapping things. Again, population has an entire group, that's everybody. Is population a sample is a subset, so it's just picking part of that population, part of the people from the population. And then a representative sample has characteristics of the whole population. And if we do a random sample, that's usually a way that we can get a representative sample. So we'll look at do you understand number 3? Quality control manager of a peanut butter manufacturing plant wants to ensure the quality of the peanut butter in the jars coming down the assembly line. Describe a representative sampling method she could use. So representative sampling method. So a couple ways of getting representative sampling. One option would be just to choose maybe, for example, every 10th jar, something like that, and understand that would be representative. Okay, it's not random, but it is representative. To do a random sample, we could, if we're going to do, let's say we're going to do 10,000 jars, we could make a spreadsheet. Make a spreadsheet of numbers. And randomly pick numbers on that spreadsheet. The one difficulty with that is, well, I mean, potentially with both of these methods, we got this assembly line moving. It might be hard to keep track of, well, is that the 10th jar or the 8th jar? Might lose track of that. And then, especially if we're just randomly picking numbers, I want number 117 and now I want number 136. So you have to be constantly counting all the jars. Realistically, they probably just every so often just kind of pick a jar off there and check it out and make sure it looks okay. Other methods, some other people suggested just having people watching the different processes, making sure on the stage where the peanut butter gets mixed that it's being mixed properly, making sure that the containers are being sealed properly, before the lids get put on. Okay, we look at do you know how, number 4. A health club manager wants to determine whether the members would prefer a new sauna or a new steam room. The club surveys 50 of its 600 members. What is the population of this study? So population involves everyone, so population is all 600 members of the health club. If we look at number 5, a journalism teacher wants to determine whether his students would prefer to attend a national writing convention or tour of a local newspaper press. The journalism teacher has a total of 120 students in 4 different classes. What would be a representative sample in this situation? So remember we talked about earlier, representative sample, everybody has a chance to be asked. So what we could do, one option would be put names in a hat. So you could put names in a hat and draw out some names. Another option would be we could just randomly select students from each class. Again, just making sure that everybody has a chance to be part of our study. Not everybody's going to be asked, but everybody at least has a chance to be asked.